So a few ways to do this proof. I'm going to establish that it's a parallelogram first, using alternate interior angles to get parallel sides. Then I'm going to prove that it's a rhombus because it's a parallelogram with a pair of consecutive sides congruent. So let's go through that process. What I need first, I'm going to pick the givens that are going to help me get the fact that it's a parallelogram. So angle 1 being congruent to angle 2, and angle 3 being congruent to angle 4 are the keys for that. I could put all the givens in here at once, but I'm just going to place the ones that I'm using first. So angle 1 congruent to angle 2, that actually, what that gives us is that SR is parallel to PQ. Okay, and 3 congruent to angle 4 actually gives us PS congruent to QR. And PS, not congruent, I'm sorry, parallel to QR. Because when alternate interior angles are congruent, I'm going to write it out. Lines cut by a transversal are parallel. Now, you could probably get away with saying alternate interior angles theorem, but I'm just writing it out to make sure we all know what that means. Now I'm going to say PQRS is a parallelogram because both pairs of opposite sides are congruent. Okay. All right. Now we'll go get a pair of adjacent sides congruent, which upgrades it to a rhombus. All right. The fact that angle 2 is congruent, let's see, to angle 3. Maybe we don't need to do that. Why not? Okay. Angle 2 is congruent to angle 3. It's a little easier this way. And that's because it's given. All right. Now, angle 1 is congruent to angle 3 by substitution, or that transitive property. I'll highlight those so you can see what I'm talking about. This and this, see, 1 and 3 are both congruent to angle 2, so we can sub in, sub 1 in for angle 2 and get angle 1's congruent to angle 3. All right. Now that gives us, I am going to shortcut this, SR is congruent to QR, and that's by base angles theorem. Right, this is an isosceles triangle now because it's got two angles the same. Okay, now PQRS upgrades to a rhombus because it is a parallelogram with adjacent sides congruent. All right. Next one. It's going to be the same as 2, 2 the same as 3. They don't tell us it's a parallelogram. PQ is the same as RS. Okay. So we can do the same thing again. Get a parallelogram out of it. What I'm going to use is angle 1 congruent to angle 2 to get those parallel. So now what we have is a pair of sides, parallel and congruent. That's enough for a rhombus, and the fact that angle 1 is congruent to angle 3 makes SR and RQ the same again. We're going to use the same thing, base angles theorem. So 1, I'm going to establish angle 1 congruent to angle 2 because it's given, and I'm going to use it to get me SR is parallel to PQ by alternate. This time I am going to shortcut it with a theorem, alternate interior angles theorem, which I wrote out up above. Okay. Now, PQ is congruent to RS because it's given. And now we have a parallelogram. So PQRS is a parallelogram because it has a pair of opposite sides that are both parallel and congruent. All right, now let's upgrade it. All right, angle 1, angle 2 congruent to angle 3 is given. So again, we're going to have to use that substitution. Okay. So I'll highlight those. 2 and 3 are the same, 1 and 2 are the same again. Angle 1 now is the same as angle 3 by substitution. Which makes SR congruent to RQ by base angles theorem. And again, PQRS is now upgraded to a rhombus because it is a parallelogram with a pair of adjacent sides congruent. That's all it takes. All right, take care of number 7. These get a little bit tricky. So what we have is a rectangle, ABCD. I'm just going to draw another one just so we can work on it. So they first give us it's a rectangle, and in a rectangle we both have right angles or we have congruent diagonals. You know, those are some of the properties of rectangle. Now the fact that ABX is congruent to XBC will be able to give us some information to continue with. Now to make this a square, if we have a rectangle, what we kind of need is AB congruent to BC somehow. If we can get that, we'll be able to finish it off. All right, let's simplify this proof. I did find a simpler way. So what we could do instead, since ABCD is a rectangle, all we have to do is get a pair of sides the same, which is going to be pretty easy to do. A pair of adjacent sides the same, and that's going to upgrade it to a, instead of upgrading it to a rhombus, it's going to be a rhombus and a rectangle, which is a square. So because it's a rectangle, what we have is AB is parallel to CD, and that is because opposite sides of a rectangle are parallel. All right. So now what we're going to do is, what we're going to say is, this gives us angle ABX is congruent to angle CDX. So that's what I've marked right here. These two are the same now. Okay? And that's by alternate interior angles theorem. Kind of see that Z that's happening right there, right? So that forces this and this to be congruent. All right. Now, it was given that angle ABX was congruent to angle XBC. And now we can use substitution to get us angle CDX is congruent to angle XBC by substitution. I'm going to now be able to say, what you notice is what we have here is an isosceles triangle now. So those are the same. So CD is going to be congruent to CB by base angles theorem. It's now an isosceles triangle. And finally, ABCD upgraded to a square, because it is a rectangle with adjacent sides congruent.